So, hello everyone. I think we can get started, so please take a seat if you want. Really nice to see so many show up at a topic about code quality. I mean, I do some other talks as well about things like Docker and automating Lego trains with Raspberry Pis, and most of the time they are quite popular, but as soon as you talk about code quality, nobody cares anymore, and that's quite strange. So I'm really happy you all showed up for this talk. First of all, my name is Johan Janssen. I work at a company called InfoSupport, so I don't work for SonarQube or anything. So not be afraid, I don't try to sell you anything. I sort of try to sell you SonarQube, but I won't benefit from it. So you don't have to be afraid for that. And in this talk, I'm going to give you like an overview of some of the more advanced features that SonarQube can offer you to use in your project. So it will not be in-depth, because SonarQube has way too many features to go in-depth in 40 minutes. So I just touch the topics so that you know what is possible and can try them for yourselves, or maybe afterwards ask me if you need any help with it or have any additional questions. So this is more or less the content for today. If you have any questions in between, feel free to ask them, but I have a hard time seeing you with the lights, so just shout if you have a question. But first, yeah, what about quality? I mean, the pyramids, they were built quite well. I mean, they are still there after thousands of years, and the Egyptians still make lots and lots of money of it. So it's really profitable, I think. There are other situations where quality was a bit less, so afterwards you have to spend a lot of money to fix the problems, in this case, to get it straight again. And if you fix those problems, you can again make lots of money with it. So I think the same goes for software development. And in Holland we had a train. I don't know if you went to the no estimates talk, but for this train there were sort of two estimates or two options. Either the train didn't arrive at all at your station, or it broke down during your travel. So after 39 days they stopped using these trains and just gave them all away, and it cost millions of bucks. So I think it's good to have good quality stuff, and that's the same for software, of course. So a little introduction about SonarQube. For the who of you have used SonarQube before and know what it is? Please raise your hand. Oh, okay, so quite a few, nice. To ask one other question, who of you used the Pitest plugin in SonarQube? Nobody? So everybody will learn something today, so that's nice. But SonarQube, it's more like, it started like a dashboard to show Checkstyle, find bugs and PMD errors in your code. So ranging from possible null pointers to just formatting issues, displaying unit test and unit test coverage and stuff like that. But it's much more advanced now. They even replaced Checkstyle and PMD with their own checks, and they support .NET nowadays. Microsoft is a big sponsor of them and is helping them improving their software. And it's really well maintained, and if you have any questions you can get easily answers on the mailing list and everything. So it's really nice to use. And they release about 6 major versions each year, which offer you new improvements and new features that you have. And it can be extended by lots of plugins. So it's really a plugin framework where you can write your own stuff and plug it in. But what about the basic features? So this is a bit of an overview of the basic features. Like, you can see what your lines of code are, how many duplications you have, what the unit test coverage is, which like Checkstyle or PMD issues you have. And you can define then also alerts, certain thresholds when it's too high for your project, so that you can get an even more visual view of it. So this is more or less a bit the basics of it. And if you look a step further, they have some nice features like seeing the changes over time. So here it's showing the changes over the last 30 days, but you could also define the changes over the last 14 days. If you have a sprint of 2 weeks, then you can say how the code quality changed during that sprint. So you can see, for instance, that the issues, there were quite some issues introduced in the last 30 days. So that's probably something you don't want. And especially if you have already a project which is existing and has lots of issues, you probably can't fix all those issues at once. But you don't want to introduce new issues, because then it's garbage on garbage on garbage. And with this you can easily see if it's improving or not. To use it, you can use different languages in SonarQube, like for instance CSS, Java, JavaScript, and you can introduce them. They have their own profiles where you some checks you can enable them or disable those checks and say how the severity of every check is and everything. But they offer some standard profiles which you can use, and that's a good basis to get starting. So yeah, this is more the quality gate. So you can define like, oh, I'm okay if I have minor issues, I don't really care, but I don't want to have any major issues. Or what you see here is I don't want to introduce any new issues. So that's also helpful if you have an existing project which is of less quality than what you want. And then with this you can make sure that at least there's nothing new added that is of low quality. You can also use it to compare it. And comparing it, I think it's a nice feature because some metrics SonarQube gives you, they are hard to say if it's good or not good. I mean, if a unit test fails, it's bad, of course. You have to fix it, and then it's okay. But what do you do, for instance, like complexity per function? I mean, is 0.7, is that high, or is 10.6 really high? I have no idea. So what you then can do is you can compare it to different projects or to different versions of the same project. Like you can see here, I compared 2 versions of SonarQube against some example that I made myself. And that's a way to see how your project is doing compared to some other projects. You can also do measures. This is a bit the Google for SonarQube, so you can do some queries on your files or on your projects. For instance here, I say I want all the files where the number of duplicated lines is more than 5, and then I get a list of all those files and I can look into it and yes, more search for the points in your code that are really bad and try and improve those. I mean, SonarQube is a useful tool. I mean, it can find lots of issues for you, but still, I mean, coding, it's something that a computer cannot check if everything is okay. If you, for instance, use variable names like x1, x2, y, z, SonarQube won't complain. I mean, it's perfectly valid code and you don't have any issues with it. But the readability of your code is pretty crappy. So code reviews, manual code reviews, I think they're still really important. Probably everybody has read this already, so I won't explain it further. But you can do code reviews manual in SonarQube as well. So you can just click on a piece of code and say like, oh yeah, I think this is not good, improve it. And then it's an issue. The same way as you have Checkstyle issues, you can also have code review issues. So then SonarQube keeps track of the code review issues as well. And you don't need a separate tool for it. It's all just integrated within SonarQube. I mean, probably this is really visible already. It's not really practical to design stuff like this, so probably they changed it. But with code, sometimes it's a little more difficult to find issues, especially in architectural level. And SonarQube is giving some help in that area as well. What they have, for instance, is architectural constraints. For instance, if you have in Java, you have a few packages. One package is for front-end, one package is for servers, and one package is for back-end. And you always want that the front-end package communicates to the service package and the service package to the back-end package. Front-end package should never directly contact the back-end package. And you can define that here. So we say we don't allow front-end to back-end. You specify which the packages are. And then in the next slide here we see an example. So this class is in the front-end package and it's using something from the back-end package, and you immediately get an issue. So this way you can define some architectural rules within SonarQube, and then the code is automatically checked if any of the developer isn't doing something messy. So that's quite helpful. Another helpful thing is package tangle index. So here you see like 2 classes from different packages. Or no, we go to the next slide, that's easier. So this is the front-end package. We have a front-end or location controller in it, and it's using a location service in the service package. And in the service package, we have a person service, and that's using something in the front-end package, which is the person controller. So you have a cycle between different packages, and typically that's not really well designed of your application, because typically you just have one flow through the application. And you can easily detect those issues with SonarQube as well. Testing. Testing is quite hard. Often testing is a bit neglected to writing normal code because people, they don't really like testing, or they think test unit test quality is not as important as my code quality. And SonarQube is giving you some help to make sure your tests are better and you can use the results of your tests better. And one of these things is, for instance, that you can see the coverage for every test. So here we see a piece of code, and we can see which test methods are covering this piece of code. And we can click through, and then here we see the test, and we can see which actual code is covered by this test. So you can easily see, like, oh, this piece of code, it's tested like 3 times, and it's tested by these methods. And this piece isn't tested at all, so I have to add an extra test, and then you run SonarQube again, and hopefully you can see that now everything is covered, and you can see by which tests everything is covered. Something else that I found really useful, if we do like functional testing, we walk through a part in the application, we just call the UI. Most of the time we have an Angular app, a front end, or some other JavaScript front end. And we call the UI, we click through a part through the application, and if it doesn't fail, then we're happy, because it doesn't fail. But we don't really relate it to how much of the code is covered by those actual functional tests. And of course, it's a big debate. If you say the same to testers, they say, oh no, you should never relate functional tests to code coverage. And maybe not strictly, but I mean, if you have functional tests that cover like 90% of your functionality, or maybe even 100% of your functionality, and you then measure how much code is covered by those tests, and it's only 10%, then probably you can throw away 90% of your code, because it's that code. Or some exotic situation that maybe never happens. So this can help you to measure coverage, and it doesn't matter what kind of test you're running. If you're running a performance test, or somebody's doing a manual test, or automatic functional testing, you can just say to, for instance, here it's Tomcat, but I tried it, for instance, with a JBoss application server as well. You can just add a Java agent, which is measuring all the coverage on all the files that are being instrumented during your test run. And those results, they are then stored somewhere. And we can then say to SonarQube, hey, we want to use those results, and that's our integration report. And then SonarQube will make sure that it's nicely displayed next to your unit test coverage. So what we can see here is, so this is the unit test. We can see that this is covered by unit tests, and this is the integration test, and we can see the constructor isn't covered, but this piece of code is covered by the functional test. So that's really nice and visible. And another thing that's working quite well is PMD rules. Mostly projects use PMD rules or Checkstyle rules for normal code, but on unit test code, normally there are no rules really. So it gets a bit messy and not really useful anymore. And luckily now PMD has a set of rules which you can use, which is a nice basis to get started, to bring more structure to your unit tests and take them to the same quality level of your normal code. And that's really helpful, because it's all automated and you just have to enable them. It's not a lot of work. Then we come to the Pitest plugin. If I want you to remember one thing from this presentation, it's Pitest. You can forget about the rest if you don't want to use it or don't like it, but Pitest, it's a really cool thing. What Pitest is doing, Pitest, by the way, it isn't SonarQube specific, it's just a general framework or tool, however you want to call it. And what it does, it is doing mutation testing. So a unit test is run. If the unit test is successful, the underlying code is changed. So not the code of the unit test, but the actual code is changed. So booleans are inverted, relational operators are changed. And then the test is run again. And if the test is still okay, still succeeds, then it's a lousy test, because your code is changed and the test is still running. You can probably throw it away, and it's probably a test that's merely there to get code coverage. And that's something we see at a lot of projects. People are mainly steering on numbers like how many unit tests do you have and how many coverage do you have, but it's saying nothing. I mean, I can get 100% of coverage with all lousy tests. Just call every method and don't do anything with it, and I have 100% of coverage. And with this tool, you can easily see which tests are good and which are not good. Other languages, we already saw a bit in the beginning, but there's excellent support also for instance, JavaScript. So nowadays, lots of teams use JavaScript for their front end, and you can use that in SonarQube as well to check for the code quality. The same goes for CSS. It's also something almost every project has, and CSS files also have the tendency to get quite messy over a certain time. So with this plugin, you can increase that quality at least a bit. Some other plugins. This is about Eclipse, but I think the same is working in IntelliJ and maybe even some other IDEs. You can just run the test and run SonarQube from within your IDE. So you don't have to go to the browser and look at the SonarQube results. You can just view them in your IDE. You can mark issues in your IDE. So it's all basically in one screen. And what's really cool about it is you can do incremental analysis. That means that only the code that you changed is analyzed. So analysis is much quicker than doing a full scan over your complete code base. So that's a really nice feature. And it can make sure that your code is of good quality before you push something to the central repository where SonarQube is run. You can already upfront see, hey, is my code good enough to be committed? Because the nice thing is with this analysis, the profiles and settings from your server are used. So it is just making a connection to your server, retrieving the settings and doing a local analysis for you, but yeah, with the same checks as on the server. So that's really nice. And the other option is to run SonarQube yourself locally, but then you have to make sure that locally you have the exact same checks and profiles as on the build server, and that's not really convenient. The SEM activity plugin, this is a plugin you can use, for instance, with Git, and you can see which lines are changed by whom. So if you see a new issue or some crappy code, you can immediately walk to someone and say, hey, you made crappy code. Yeah. Sounds good in theory, but in practice, if someone just changes like the formatting of a file, then he has changed all the lines and maybe not introduced that bug. So before you start yelling at people, it's good to first see, hey, is it really that person that introduced it? But it's a good way to quickly see like, hey, colleague, I see this and this in your code. Did you introduce it? Or maybe we have to have a look at it. So that's really easy. Boostability plugin. It's something I found really useful because SonarQube it displays in some corner when the latest analysis was. But maybe like the latest analysis didn't succeed because there was an issue in Jenkins or something like that. And then you think your code is okay. You see okay results in SonarQube. But in the end, the project wasn't built properly. And that's kind of annoying because you probably only found out after a week or 2 weeks. And then you have to fix everything that's happened in those 2 weeks. With the Boostability plugin, you can easily see which builds in Jenkins succeeded and failed, how long they took, and you can even see how long it took to fix the build after it was broken. So that's really helpful. Then we have duplication across projects. So normally you only see the duplications within your project, which is quite interesting. But if you're in a bigger company, it can also be useful to see, hey, are we using lots of duplications across projects? Because then maybe it makes sense to create separate projects of those duplications and use those projects in all the projects that need that functionality. And you can just enable that within SonarQube. By default, it's disabled because it's quite a heavy analysis. It has to compare all the code with all the projects that are existing. So if you enable it, builds will take quite a lot longer. So keep that in mind, but it can be really useful to see where certain code is used. For instance, here we see we have the Docker Py example project, and here we have the test application, and it's using the exact same code as the Docker Py example. So that's easy to see. Hotspots. Hotspots is really useful if you have an existing application, because I don't know how it's here in Serbia, but in Holland, if we take over an application from another team, it's usually crappy. At least we think it's crappy, but probably they think the same from our code because everybody has their own standards and things they like more or don't like at all. But the nice thing is with this one, you can see like where are the major issues in your application, because if you have lots of issues, you cannot just refactor everything. You need some kind of a strategy. And one good strategy would be to look at the files where maybe most violations are, or the files which have high complexity, because if a file has a high complexity, there's lots of logic in it, then it's probably good that that file is of good quality because lots of stuff is happening there, and if something goes wrong, you probably have a problem. And here you can, for instance, see like what the most violated rules are, which files are have the most violations, and you can see here this is the most complex Java class. So it's the most complex and the most crappy one, so probably an ideal candidate to start your refactor process. Some other examples, not of code, but yeah, I mean, you probably get it that this is not really what you want. So probably the guys that built this, they got something to hear from their boss. The boss probably complained or the customer complained and they had to change it, and probably they learned from it and the next time they don't do it again. At least I hope they don't do it again. With software development, it's a little bit different. I mean, people sometimes are afraid of comments from their colleagues, or they think tools like SonarQube are mainly a management tool to punish you. But actually, I mean, SonarQube can help you become a better developer. If you use these tools, you don't make the same mistakes over and over again. And your colleagues won't complain about your code because you have seen the issues already yourself. So it will help you instead of your manager. And I think that's a transition a lot of developers have to make. You have to stand open for criticism, and if you get critics from your colleagues, it's really good because then you can improve and gradually become a better developer. It's not that your colleague tries to punish you or whatever. It's just, yeah, we have to help each other as colleagues and make sure that we deliver good quality code that ends up in production and doesn't cause any bugs there. And that's, I think, is a mentality that is gradually changing a bit in software development, but it can still be a lot better than it is nowadays. Because, I mean, you have to accept there is no single developer that isn't introducing any bugs. It's a fact. I mean, Microsoft, they have some statistics about how many issues were introduced in every so many lines of code their developers are writing. Of course, we're in Java conference and we usually write better code than the guys at Microsoft, but still, even Google, they have bugs in their code and they're really excellent developers. So it's good to accept the fact that you are failing. I mean, you make mistakes, but the thing is try to find it as quickly as possible. Try to make sure you don't make that same mistake over and over again. Okay, then thank you for your attention.